it's better. Just need to.
In Latvian language, there are students for this. How much?
Also, not so many I would like. One bachelor program. Get the engineer qualification disappear.
Oh.
How see what will happen? It's a new program.
Yeah, this smart core system.
Yeah, it's smart professional. Before we had academic and engineer program, all obsolete. I decided to close them all and start the new one with the support from some program.
Yeah, I think they will stop this program next year. Shortage of students.
I'm not sure what will happen. Something should happen. We can't just waste money.
Yeah, and your valuable time also.
No one cares. Really, question is only about finance. Okay, I need to start editing. I will add everything fine except some very strange. Stop. My mistake is. I understood. Tiny mistake. Now it's fine. Okay, I can cut this. Later I can put an example. Where am I? What am I doing? I need to I need okay, what I need to switch to my small presentation and switch on my TV. Here. Yeah, I can appear in front of camera to say hello to someone who may be willing to watch this video. But what I'm willing to talk today is a solution of DC networks. How to solve a DC network with the, of course, numerical solve with the help of such environment as SciLab. It's free for students, but the key moment how to solve a DC network. It's one of the classics. But what? Sorry, I have opened a wrong presentation. One moment. It's my mistake. This is wrong presentation. It's a presentation for it was a presentation for AC network. No, we need this one. Who are these guys? On the left, Gustav Kirchhoff, former of Kirchhoff's law, Kirchhoff's current and voltage law. And on the opposite side, Georg Simon Ohm, former of Ohm law. So with the help of Kirchhoff and Ohm, I will solve a DC network. For example, I have this. This is DC network I need to solve. It's more theoretical, it's practice, but we will use it in real life, solving real networks, but with some addition. We cannot start real networks before we have let's say some practice in this theoretical ideal network. This network is ideal. It contains of resistance, several EMFs, and one current source. Everything what electrotechnics theory can offer us. How can we solve such type of network? What means solve at first? We need to know voltages at all nodes and currents in all branches. Yes? Yes. So the first step, we need to define a reference point or base node. In future, we will speak not only about base node, but about so-called slack bus or balancing node. These all connected ideas. We will start from simple node where we assume zero voltage. Let's say it's a ground. In such theoretical tasks, I can select any node on my choice. It's absolutely free. In reality, I will need to think where is the voltage controller, where is the power plant that maintains the energy balance. In reality, my hands are not so free. But here we have pure theory, and when we have a pure theory, move here, we can use any node. So I would like to use this one. I marked it with a green triangle. It's my base with the voltage 0. It's a 0 voltage. Okay. Next step. I will assign green numbers to all nodes. 1, 2, 3, 4. Base 5 and 6. As I would like. It's my free choice. Also, I need to assign numbers and directions to branches. I will use techniques of topological analysis requiring me to create a so-called directed graph. So each branch should have not only number but also direction. I have Roman number first, number. This one is first, this one is second. Which one is third? It was somewhere. It's number 10.
R6.
Yeah. I see it. Between base and node number 4. Here it is. Okay, so I have assigned numbers. Now I can conduct a matrix representing these schematics in, let's say, digital form or computable form. it will be first incidence matrix or matrix of first Kirchhoff. Make it smaller. Here is the conduction rule. Can I hide this thing? Here is the conduction rule. So, row number corresponds to number of nodes. Base node should not be included with a huge exclamation mark. And number of column corresponds to number of branch. Mezgals is node, zags is branch. So I will get this one.
Matrix.
Yeah, this table, it is not a matrix. Now it's a table.
Okay, not table,
1 second and it will become matrix.
Okay.
Here it is. It's a nice table. How did I, for example, branch 1 from node 5 to node 1. See, here it is. From 5 to 1. And in my table, from 5 to 1. Branch 2, wait, why number 2? Yeah, from 5 to 6. Here is number 2. From 5 to 6. From 5 to 6. Flow goes out 1, inflows minus 1. No connection, 0. Which one? The third. From the base to number 4. Here it is. We don't have base node here. It's not needed. And number 4, here it is.
Incoming negative.
Yeah.
Okay.
Number 5. This is number 5. From 6 to 4.
Okay.
From 6 to 4.
4 negative 1 6.
Number 5. 6 leaving 1, arriving, incoming.
Negative.
Number 4 minus 1. So I have this table. It tells me what? Structure, topology. It is not a matrix, but 1 second. I'll switch to here. I need to be here. Here is my program in SciLab environment. I have started text document. Look, this one. It's my table, but now it's a matrix. I'm assigning M capital in square parentheses. As I conduct a table, here my table becomes matrix. And it's in form, it's in PC form, it's for computer. Now it's a part of program. This semicolon for SciLab means nothing. If you use MATLAB, it means no print. Let's go forward. Next step we may need, it's for electrotechnics. Theory. We can apply different techniques. We can rely on node voltage, but we can also use contour currents. For practical tasks, contour currents are used rarely. It's not a popular technique. But we have a good example. Let's do a good example. For a good example, what should I need to select contours. Round trip or round travel charts or schemes or routes as you want. So it should be a set of branches which some imaginary traveler can walk around. My task. First, I look on my first incidence matrix. What I got here? What I see? I see 11 branches and 6 nodes. 11 minus 6 means 5. I need to specify 5 contours. I'll do this one. First, second, third, and so on. I can also take, for example, this one or something like this. Go this way. Any set of branches making or forming a round trip route. It's okay. But there's one moment. I need an independent. So I can draw a tree from a base node. Branch is not included in tree chords. So each contour must contain at least one chord. This will make it independent. Okay, I did it like this. So my schematics, my rules. For each contour, I should assign number and direction. My imaginable traveler will walk clockwise or counterclockwise. And I can conduct this contour matrix or second incidence matrix. Idea: column number is a branch, number of the branch. A row number is number of the contour. If branch flows in this contour traveling direction, write +1. If flow goes in opposite, write -1. Yeah, your way.
Yeah, yes, sir.
Yeah. So here we are. Here is my, take a look, my schematics and second incidence matrix describing it. For example, branch 1. Here is branch 1. First contour, no connection. Second, B, no connection. Third, C. Where is the C? Here is the C. No connection. D. Oh yeah, D is walked clockwise. And branch 1 flows in clockwise direction. So I'm writing 1. Branch 2. Where are you, branch 2? Yeah, here is my branch 2. I have C and D contour. D counterclockwise. D will walk clockwise, but my branch flows up. So -1. E, branch flows up, contour walk this way. It's 1. Number 3. C and again contours walk this way clockwise, but branch flows up, so -1, and so on. You can see here is my schematics and corresponding contour matrix. When okay, this is table. I have conducted this nice table, everything visible. Now it should become a matrix. Here. In my SciLab environment, I have put M and matrices. Next one, this nice vector of EMF. How did I get it? One moment. Please, I believe. Yeah, it's time to conduct EMF E. It's a column vector with row number equivalent to branch number. If EMF is co-directed, I should write its value with the plus. If it falls against the branch direction, I'm write it with the negative. Here, strangely all positives. First branch, no EMF. Number 7, for example, case. Number 7, first EMF in the number 7 and in co-direction. So, case number 7 and 10 volts for the first EMF. Easy. Simple technology. Now, resistance. What about resistance? In general, resistance matrix is a square with the diagonal field with branch resistances and other wait 1 second, there should be one closer. Okay, yeah, put it in. Don't worry, it will not kill you.
Just turn it. You are acting like
There is no power.
No.
Now it is.
Now it's work, yes.
Okay, what's the idea? In general, I need square table with the diagonal field with resistance values. But what that sense to write dozens of zeros? I will fill only column with resistance and form a diagonal matrix later. So take a look. Resistance of the first branch, of second, of third, and so on. Very easy. Resistance of the branches. Here. Here are resistance of the branches. You can see it. Current source. Here I have two vectors of current source. For each technique I will use, I need own special current source vector. Each technique requires own way of current vector conduct. For the nodal voltage, I use simple current source vector. Vertical table, row corresponds to the number of nodes. If current source falls in node, we should write it with the plus sign. If it runs from node or falls from this node, write it with the minus. Here it is very simple. In my schematic, from the 6 to the 3rd. Take a look. 6 minus 5, 3rd plus 5. But counter current technique based on the second Kirchhoff. For the contour current, the assumption, assuming that each contour has its own contour current, I need a way to introduce energy from current source into second Kirchhoff law. To do so, what I should do? I should specify so-called additional or fake or supplementary contour for the current source, for each current source. It's a set of branches making a round trip route for the current of this source. For my source, I show it with like this. Here it is. I'm assuming what this current flows through 9th and 5th branch. It's a so-called supplementary or additional contour for the current source. And I'll need to conduct a vector or table for this fake or supplementary current. If it's a table, position corresponds to number of branch, and if current flows in the branch direction, co-directed with the branch, I should write it with a plus sign. If flows against, I'll write it with a negative sign. And I will get something like this. In my case, both in opposite. Each current source requires such vector for such supplemental contour, and will be reflected in this vector for technique of contour color. Now I can switch here. Here are two matrices. Now they are matrices for current sources. They have the same info. They are conducted. First incidence M multiplied by this J equals to I. But there is no way to perform an opposite inverse operation. There is no way to uniformly get G from I. Okay, now machine will work. Actually, this is all what I need to do by hand. Now, human works at here. These 3 rows. Can you see them? Yeah. I would like to create a reusable code program that can be used for any network. So I will not code dimensions rigidly. I will use measuring function. This is nice function, size. It means take a measure from the array. And it has 2 inputs. First, name of array to measure, and second one, direction of measurements or dimension. 1 means what it will measure, number of rows, 2 means number of columns, and 3 number of layers. So the first dimension is a number of nodes. Here you can see MS, it's from Latvian mezglu skaits, it's a number of nodes. I can do a comment, it's number of nodes. ZS, it's from Latvian zaru skaits, number of branch. Zars is branch in Latvian, so here we will have number of. And the third one, KS, contours, what in Latvian it is also contours. Contours. So KS, it's a contour skaits in Latvian, or in English, number of contours. Number of contours. see, I got a number of elements. Next step, this one. I have used fourth cycle. What is fourth cycle? An idea? This one. For example, this one. Okay. Starting from here and ending here. What's mean? For machine, start counting. I. Start counting. I should be 1, 2, 3, so and until number of nodes. Here inside machine count G starting from 1 and 2 number of branch. And inside what machine should do? It should put in MT or M transpose. What means transpose of matrix? Row change, row and columns are rows are swapped with columns. Yeah, it's a transpose of matrix. I need a transpose with nodal matrix. This part will produce what? Transposed second incidence matrix. I'll need these two transposed matrices. First, use with this row. There is one interesting moment with node branch and node contour matrix. If you multiply first incidence M with transposed second or transposed second with the first incidence, you should get a square matrix of zeros. It's a way to check coherence of this matrix. And the second idea, M multiplied by G equals to I. So this one should produce 0. Take a look what I'm doing. I will activate execute with echo tilde the current. Control E will execute what I have written, tilde the current, so tilde the place where here it is number 40, my current, with echo. Machine, do it. And what machine done? Execution. Environment loaded. Network started. Matrix loaded. Matrix. This one is okay. Human work, blah, blah, blah. Number of nodes, number of branch, number of contours. Transpose executed. This executed. Checks 1 and 2. This operator. Show me. In apostrophe is a text. Case result. Check. I should get zeros. Take a look. I get my zeros. And also, this check also yields 0. Just to illustrate, take a look. I will make a mistake. For example, I will. It's stupid, but here execute till caret. See? 2. Not 0. It just means what I make a mistake. They are not coherent. I don't know. Stupid mistake like this. Branch can only have 2 nodes. Okay, branch with 3 nodes. Here. And where are you? See? It's a result. Not 0. I made a mistake. This way. Did I fix my mistakes? Okay, it's 0, 0, zeros, all zeros. I can go forward. Next step, to create a nodal admittance matrix and to apply Ohm law, I need inverted resistance matrix. There is one small problem with the matrix mass. What problem? It has plus, minus, multiply, but no division operator is defined for matrix. I should multiply with its inverse matrix. It is quite hard to find something more easier than inversion of pure diagonal matrix. So here I just inverting main diagonal of the resistance matrix. And why should I form this diag? Okay, I use that. In general, I can I need. Okay, let's go for this part. It's a key. I calculate nodal admittance matrix. It's a key element of nodal voltage technique. Also, B part 3 elements. I need to solve an equation system, linear equation system GAU equals to I minus M inverted E. It's a system of linear equation. I can use a Gauss technique built in SciLab. Or I can use iterative solution. But at the first approach, here is the Gauss. I will show how to use an iterative. Built-in Gauss method. And I can show my nodal voltages. What means so? I should get nodal voltage and branch currents, yeah? Ohm's law help me to get my branch currents. Blah, blah, blah. So check time to calculate inverse nodal admittance matrix, nodal voltage equation, solution, branch currents, easy. Okay, let's see it's executed here. Execute till current. Here it is. Look at it. Nodal admittance matrix. Take a look on structure. Positive values on main diagonal. It's a sum of all branch conductiveness. For this one for the first node, this one for the second, this for third. And other elements with a minus sign mutual conductance or conductance between nodes. This 1, 2 is a conductance between first and second node. 1, 3, 1, 4, 1, 6 conductance between 1, 1, 2, 1, 3, 1, 4, 1, 5. This one is conductance between first and fifth node with the minus sign. 3 elements Gauss works and are voltages and nodal voltage method produced a current. In general, I have solved my network, but machine works. Contour current technique. I will need to solve an equation RK. RK equals to AK. Contour resistance matrix and Rn transpose. Contour EMF vector and multiplied by A minus Rg. Solution with the Gauss. Solved. 1 second. What I got? 1 second. I will. 1 second. I will remove. Here. Contour currents. Matrix of contour resistance. Again, main diagonal positive values. These are sums of all branch resistance for the contour. First, this one, all branches in first contour, all branches in second contour, all branches in third contour. And resistance of common branch between contours. 1, 2 is a common resistance between first and second. 1, 4 common resistance between first and fourth. Contour EMF vector. Solution. Here are contour, these imaginable currents for each contour. Here they are. Real currents from the contour current. Contour currents are what? They are equal to real currents for branch for let's say single branch, and they are something when branch is shared between contours. Here are real currents. Did I solve well? How can I check myself? I can compare currents from two techniques. This digit, see this? Minus 16, minus 16, minus 16. It means 16 digit after the comma. So I have solved quite good. It's a max what Pentium-like processors can produce, much precision. What can I do? For the guts of the electrotechnics theory, I can check Kirchhoff. This part, I'm forming a matrices of Kirchhoff equation. Kirchhoff law matrix. First Kirchhoff, second Kirchhoff. B vector, right side. for the first Kirchhoff, for the second Kirchhoff. Now, look at them. Here is the matrix of system state by Kirchhoff. Upper part is the first Kirchhoff, lower part second Kirchhoff. Not so nicely organized matrix. It's a sparse matrix, a lot of zeros and non-uniform structure. B part, here is the check of the Kirchhoff law. As you can see, I have checked my currents. As you can see, very good, 15, 16 numbers after the column. Good. Can I go forward? I can do one more check. It's called a balance of power. Energy supplied by EMF and current sources should be equal to energy dissipated by resistance. Yeah? Here it is. So, here I use the for cycle, 1, 2, 3, 4, 5, for the purpose, for the two purposes. First, power of passive element. It's in each branch, dissipated power will be square of the current multiplied by branch resistance. Yeah? Square of the current, branch resistance. And I need to sum them all. That's why I'm writing PP equals to PP plus. For each EMF in each branch, energy supplied to the network will be EMF magnitude multiplied by branch current. Here is the power, it's not an energy, it's a power in watts, but it will be multiplication of EMF magnitude by branch current, and I need to sum them all for the balance. Remaining part, I need to account current sources. So, again, it's a sum of all, and in each node, I take a node voltage multiplied by inflowing or outflowing current of the current source. This will give me an power, not energy, but watts power, supplied by current sources. Balance of power. What should I get in theory for this? What should I get for the blue? Minus PE plus PE. Results? PE is from EMF, total power PG from current source. Again, balance.
What is PP?
Passive power, power dissipated by passive element. Sum of all resistance heatings. Energy balance and power balance should be zero. As much energy spent in general to heating, as much energy is supplied by EMF and current source. Yeah? Let's check. Let's take a look. Here. Heating 294 watts. EMF supplied 22.5 of watts. Current source is 271. And you can see balance of power. 15
Manage.
minus 15. Meaning, oh, meaning what, it's quite good. I solved network, appears nice. One more moment. When I solve contour currents, if I would like to solve Kirchhoff equation, what will I get? Currents, yeah? But how will I get my voltages? Solve network means get all node voltage and all branch currents, yeah? Yeah. Where are my voltages? I can use an Ohm law by multiplication, multiplying by a transposed M matrix. I can use this, but it's much easier to solve a system of linear equation. This small fragment of code obtains voltages from currents. And to check myself again, I will compare voltages from nodal voltage techniques with the voltages from currents. Here, voltage obtained by method of contour current, and here is my check. Take a look. 15 digits after the call. So, in general, I have solved my network with two techniques and everything fine. One more step forward. Key idea: solution of this DC network reduces to solution of linear equation system with a specific kind of matrix. Here it is, specific kind of matrix with diagonal dominance. For such kind of matrix, more effective technique to solve is not to use a Gauss, but method of sequential approximation or Zeldin technique. Idea of Zeldin technique is what if I have a system like equal to B, I can find a solution. It's a solution. It's a value of x making it true via the step of sequential. I will be closer and closer. Sequential step in this way. I should create a C matrix in the way of minus I divided by I for each I from 1 to the number of equation and each G for 1 to the number of equation. Also, I will need a B vector being B divided by the same from Jacobi techniques. And on each step, next, I know, in our case, it will be I node voltage. Most probably. Can be found as a sum where will change from 1 to I minus 1. Cix next. K plus 1 means next. It's process like next, okay, previous become next, and in with this step at the infinity, we will get solution. So here, plus sum I plus 1 to the number of equation Cim xm previous plus di for each I from 1 to the number of equation. And precision of the where we are relatively to the solution, or precision can be estimated as a max absolute difference. Max. It will work with error less than 0.07. It's a technique of Seidel, technique of sequential approximation. For our business, it's very usable. First, our equation system are in form suitable for this technique. General equations not, but our with diagonal dominants are good. And second, it will help us solving real tasks. 1 second, I will show one object. Object, where are you? Seidel. Where are you? For example, this one. Here is a function. Prepare function of the Seidel solution. If you take a look, it's the same what I just have wrote on the table. Look what I will do. I will copy this example. I will save as example 2 of the DC network. Save. Now, before the matrix, I will put clear, and I will put my function here. This part will act as a reusable code. It's my own function. Now, take a look where I'm solving. I have you see, this one. I'm using my function to solve an equation system. I just declare case x next as I say Zelda, formation of C and D, and sequential approximation. BTV, I'm not happy with. Wait 1 second, I will make it a bit better. I can do this. I can do this. This one. I will make it a bit more compact. I hope it will work. bit more. This is not necessary. This is also not necessary. Technique of sequential. Closer. Next. It's next. Let's check. Do it work? Oh, sorry. My mistake. My mistake. What? 123 function. Sorry. Mm. 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 Where is my result? Where is my result? This key. Mhm. Mhm. Okay. Now I have a result. Here my nodal voltage by Gauss, and here my nodal voltage by technique of Seidel, and difference between them 10 digits. And if I can do one thing with the Seidel technique, I can control precision. 10 digits. No, I'm greedy. 5 digits. Where is my... Yeah. See? Difference. 5 digit. I have ordered. I have received. I would like to have 15 digits. And here we are. 15 digits. Now I know what I will do. I will remove this. This is no longer needed. Also, I will replace solution of the contour current by Gauss with the solution by Seidel. It will save some time for me. I will not it's okay, and here also. Will it work? At 1 get currents. Oh yeah, sorry, this was stupid. Yeah, all balance of power works. Kirchhoff check works. Checks between voltages works. Currents check by current works. So everything works fine. I got a same task solved with this built-in function of Z. Solved with the technique of sequential approximation. Where the dog is digging, why I'm doing this? I'll show when we take next problem, next one, it will be DC transport. You'll see but it is not solvable with Gauss, but solvable with Z. And similar, in general, Zeidel technique is one of the so-called upper relaxation techniques. It is also possible to speed it up with the boosting factors or speed up factors. But this one is okay. For us, this technique of sequential is fine. Do we see it? 1 second. This one. I think. What can I do? What can I do? What can I do? What can I do? I will put lecture material, example of Zeta. I will remove the old one and I will create this way, but I can do it this way. Okay, I have put these two in your e-learning system, so you can work with them. And also, do you have something like MATLAB or SciLab?
cycle function.
Yeah. Okay. So you can complete first two tasks with this. Yeah, I'm 1 second. I will put 1 second. I will put yeah. They are in the task section. Linear equation system and solution of the DC network. What's happening?
So the number of 100 number of variants.
Yeah, take your student ID, last two digit. Last two digit of your student ID number. If you
Okay. Two digital. Okay. That's that thing.
So you have now numerical solution. So it's our cited technique. I will supply. Wait 1 second. They are my computer room.
Okay.
Oh, yeah. One moment. Today we have 27th of. I need to mark attendance.
Okay.
By the way.
Okay.
Here.
Okay, the last one, Aravind and Rajendra. Yes.
Yeah, sorry. Create, and I can do it. Yeah, this one. SciLab. I will. I can, but it's not important. I can do it. For this one. It's okay. For this one. I cannot create it because I will do it. Okay, we saw it. Who is Sonic 597? I don't know. Maybe, I have 0 online viewers, so I can stop this translation.